Hello everyone, in this segment we are going to talk about the moment of inertia for the triangle, but this time we are going to estimate the IY or the moment of inertia at the Y direction. Again, we have the triangle ABC with base equal to B and height equal to H, and we have two perpendicular axes X and Y. They are intersecting at point A of that triangle. We can consider that this triangle is composed of two right-angled triangles. One is number 1 and the other one is called number 2. And for the triangle number 1, we will find that the X and Y axes are intersecting at point A, while for the other one, the Y axis and X axis intersection are apart from the line CD by distance equal to A. Before we have estimated that for the right angle triangle, we have the moment of inertia at the Y direction is equal to the HA cubed divided by 4, and this is at the Y axis in here, while our calculation for the moment of inertia at the Y direction for the line, it was based on the line DC, when the Y axis was coincide with the opposite side of the triangle. But at that regard, it is IYDC, and the value was the base to the power of 3 multiplied by the height divided by 12. So we have, in our case, where the base is B minus A, our expression can be written as IY for the line DC equal to the base B minus A raised to the power of 3 divided by 12 multiplied by H. While our IYCG was equal to B minus A to the power of 3 divided by 36 multiplied by the height H. We cannot evaluate the moment of inertia at the Y axis from using the value of the moment of inertia at the Y DC, but again we have to proceed always in order to get the moment of inertia for any location. We have to proceed from the moment of inertia at the CG, which is considered at the minimum value for any place of any shape. We have to proceed from the CG and follow the principle of parallel axis theorem. So our procedure, in order to get the moment of inertia final, we have to get the moment of inertia at the Y for triangle number 1 and the moment of inertia from triangle number 2 for X number Y. From the case number 1, we have our IY case number 1, which is this one, IY plus IYCG plus the area number 2, this is the area number 2, multiplied by the square of the horizontal distance from the CG to our Y axis. Here we have the CG distance is equal to 1/3 of the base, which will be 1/3 of B minus H. We are going to add the distance A, then we raise it to the power of 2. So we have here IY, which was B minus A raised to the power of 3 divided by 12. Sorry, B minus A raised to the power of 3 multiplied by H over 36. This is, we call it IY at the CG, plus the area number 2, which is 1/2 B minus A multiplied by H. And here we have A plus 1/3 B minus A. So 1 raised to the power of 2. We will adjust these terms. We have A and minus A, then we have 2A over 3 plus B over 3. We will raise it to the power of 2. So, and we call this one as x2. We will evaluate the x2 squared as 4A squared plus 4AB plus B squared divided by 9. So our a2 x2 squared equal to 1/2 b minus ah multiplied by 1 over 9 of open bracket 4a squared plus 4ab plus b squared. We are going to add to the IYCG, which was b minus a to the power of 3, multiplied by h over 36. Add them together and readjusting the terms by taking b minus a over 36 as a common factor multiplied by h. Then we left with b minus a inside bracket raised to the power of 2 plus, we have here 36 and we have denominator as 18. We are going to multiply by 2 of open another bracket, inner bracket, which is 4a squared plus 4ab plus b squared. We move to the next slide. Then we are going to add the condition of HA cubed divided by 4 for the triangle number 1 in order to get the IY total. So from the previous expression we have b minus a over 36 multiplied by h, and that was our factor inside the bracket, which we can more readjust by introducing b squared minus 2ba plus a squared, and we are going to add 8a squared plus 8ab plus 2b squared inside bracket. After readjustment of the terms, still we have b minus a h over 36 multiplied by, we have b squared plus 2b squared, we have 3b squared, and we have minus 2ab plus 8ab, we can write 6ab. Then we have a squared plus 8a squared, we have 9a squared inside bracket, and then we are going to add the moment of inertia at the y direction for the first triangle, which was HA cubed divided by 4. Again, we are going to adjust the terms. Still we have h over 36 and b minus a still here. We are going to introduce it inside. So we have 3b squared multiplied by b is 3b cubed plus 6ab multiplied by b, we have 6ab squared, and we have b multiplied by 9a squared, we have 9a squared b. Then again for the negative sign, minus a multiplied by 3b squared will be minus 3ab squared, this one, and we have minus a multiplied by 6ab, which is minus 6a squared b, this term. And finally, we have minus a multiplied by 9a squared, which will give us minus 9a cubed. Again, once we are making the denominator as 36, it means that we have to multiply here by 9, and we take h out. So we left with 9a cubed added. We will add it here. This 9a cubed plus minus 9 will cancel each other. And then we have 1 over 36h, open bracket, we have 3b cubed, plus we have 6ab squared minus 3ab squared, so we have plus 3ab squared, and we have 9a squared b minus 6a squared b, then we have 3a squared b. We have a common b, we'll get it out, so we have bh over 36, and also we have a 3 we'll get out, and we are left with an inner bracket, which will be b squared plus ab plus a squared. We continue in the next slide. Then we can find out that the I final value will be bh over 12, y12, because we have here 3 divided by 36. Then we have bh over 12 multiplied by b squared plus ab plus a squared. Again, we are going to return back. This is the final expression, bh over 12 multiplied by a squared plus ab plus b squared. This is the moment of inertia at the y direction for the triangle ABC. Then we can get the radius of gyration by using the law of k squared y equal to iy divided by a. So we have BH over 12 multiplied by A squared plus AB plus B squared, all divided by the area, which is 1/2 BH. Then the K squared Y will be equal to A squared plus AB plus B squared divided by 6. Next lecture, we are going to estimate the moment of inertia at the CG for the Y direction. Thanks a lot, and see you